Okay, so what I'd like to do to start out today is going over the frequently made mistakes in the programming assignment. And first of all, thanks to everybody for every single person submitted the form and submitted an assignment and at least took a decent shot at solving the problems. That's great. I think that's the first time that's ever happened. So good job. I got your comments back, as you noticed, very quickly. Hopefully I'll try to do that in the future. And what I want to do today is just go through some of the common things I saw people make as mistakes. Some people did very well, other people struggled with different parts of it, but this is meant to be a simple assignment. So if it was really hard, then I think, as I mentioned, because I probably sent you an email in that case, you may want to take CS 251 before this class, just because it gives more background on how to program object-oriented code. So let's talk about some of the common things. So a lot of people forgot to put proper exception handling in the code. So there are a lot of places where if you read the documentation, it says throw such and such if blah, 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 right? So this is a good example. There's something missing here. They didn't check and then throw an exception if there was a problem. Another common problem is people would use methods that were more complicated than they needed to be. So sometimes the methods are meant to do a certain thing and people would use them elsewhere where they didn't really belong. And so I would note that, and I'll talk a little bit about that as we get further along. There's situations where you might want to refactor. If you really want to reuse code, you want to refactor the method so that they do a common thing that doesn't do more than is necessary for the purpose. We'll talk about that a little bit later. So here's an example where calling ensure capacity internal is just overkill. It's doing extra work you don't need to be doing for the case of initializing the array, which is really very simple. Remember that by default, values that are integers get a 0, and values that are Boolean get a false, and all this kind of stuff. So you don't need to do redundant assignments in the constructor. Another common problem, a lot of people made this mistake, and I understand why, because the Java semantics for these things are subtle and confusing, but you just have to get used to them. So when you create an array with an initial capacity, the size is 0, not initial capacity, even though memory has been allocated. So go figure. That's just the way Java works. You just have to get used to that. So that shouldn't be set to initial capacity here, oddly enough. That seemed, when I first looked at this, I thought, oh, that makes sense. But when you look at what Java semantics are, it doesn't make sense. Don't use try-catch blocks to check for null pointer exceptions that can trivially be checked through other means, right? So something like this can trivially be checked just by checking to see if C is null. Don't wait for the code to blow up and then catch an exception. That's an improper way. It's way too much overhead that is unnecessary. By the way, hopefully everybody can see the slides. I'm recording this, so I'll post it so you can go back and watch it again. This was kind of bizarre. This was throwing an exception in a situation where it didn't need to be throwing an exception. Don't use equals to check for null. Just say C equal null, just to check. It's a much more efficient way to do it. And likewise, don't. What's wrong with this code? Why is that wrong? The code that says m size equal m element data dot length.
The length field from the array is different from the m size of the array.
Right. So the length is the number of elements that are allocated. M size is the number that are currently in use. And so if you have 100 elements in the array, but you've only used one of them, you don't want to have the new thing be the length. You want it to be the size, or m size. Similar problem here. This code is not checking to see if there's an exception, if an exception should be thrown. Another thing, I mentioned this a number of places on the discussion boards and in the assignments and so on. There's a lot of places where you shouldn't be using loops. You use loops, but we don't want to be using loops. We want to get in the habit of trying to use these built-in operators because they can be implemented more efficiently than doing a loop. So this is a good example. So even though having a loop here is not incorrect, I want you to use the things like toArray, copy of, erase copy of, system array copy. We'll look at some more of that stuff in a minute, but that's the stuff you should be doing there. And there's examples in the skeletons of how to do that. So here's a case. This is also more complicated than it needs to be. So you can use toArray, which is more efficient, and don't use add all. It's doing more stuff, a lot more stuff than you actually need to have done in that case. Another thing, this code is not incorrect. It's just stylistically, visually jarring to look at it. So as a rule of thumb, try to avoid stuff like if some Boolean expression is true, return true, else return false. What do you do instead?
Just return that.
Right. So you just say return size equals 0. And that's the way a programmer would write. Just too complicated. This code is too complicated because it's, for some strange reason, allocating memory in isEmpty. IsEmpty is not meant to be allocating memory. IsEmpty is just meant to check to see whether or not it's empty. So that's overkill. That kind of code belongs elsewhere. Here's another case where rather than saying msize equals 0, question mark, true or false, you just want to say return msize equals 0. This code is too complicated. This is doing a comparison of, it's doing a byte-wise comparison when it doesn't need to. A bunch of people kept checking to see whether max was greater than the max integer. Why is that a futile thing to do?
If it's bigger than the max integer anyway,
So something as bad as what, I mean, it really couldn't happen. You can't have a situation where an integer could be bigger than max integer. So it's that condition will never evaluate to true. It'll never be the case that an integer will be bigger than the max integer, because that's the max, right? So don't even bother checking for that kind of stuff. And similar thing up there when you're doing min. It's just not going to be able to happen. Okay, here's a bunch of stuff. This is subtle, and there are different ways to handle it. The get method does some extra checking, right? It does range check, which is great. We need it. But if you're doing something where you already know the element that you're using, the index, is in range, don't be calling get, because that's doing a redundant check. So as you can see here in this loop, we're always going for I equals 0, I less than m size. So there's no sense in calling get, which does a range check, because it's never going to be true, right? So it's just wasting cycles. So either just use the lower level mechanism, just the m element data subscript I. That's one thing you can do. Or if you want to, if you like the idea of factoring out common code, which is a good thing, then just make unchecked get. Make a method, a private public method called unchecked get, and call that. And don't do the range check there, of course. So that's something else to do. What is wrong with trying to use binary search here? It needs to be sorted, right? So the array is not sorted. So I don't know. That'll do something very odd. It won't return the right value unless you get really lucky. Okay, what's wrong with this comparison here? It should be equals, right? So yeah, dot equals. So this is a good example of the difference between equality and identity. Remember we talked about identity versus equality. So equal operator looks for identity. These are the same references. It's like the example I gave with a cell phone. If you have two instances of cell phone numbers and they're the same number, then of course it's the same phone. But if you have two different numbers, you don't know if it's the same person without calling the numbers, right? So you have to check some more. So this is not the right check. It'll fail. A lot of people didn't do index of correctly, and you don't check to see whether something is null and then bail out. What you have to do is you have to have two different looping conditions to check for. I do it by having two different loops, but you could do it other ways if you want to. One is where the argument O is non-null, in which case you can compare it with equals. The other case is it's null. And in that case, you have to actually check to see whether it's null. In other words, you just use equality to check each element to see whether it equals to null, equals to null. So make sure you do that correctly. The test code should catch that. If it's not, let me know. Here's an implementation of add all that's incorrect. What's wrong with this code? Why is it incorrect?
I was going to say for the index of, if you just and your like object doesn't override the object variables, it defaults the same.
No, we're talking about two different things. So if someone passes null in as the parameter, then you better not be saying O dot equals, an element data sub I,
Oh,
because
yeah.
it's going to blow up.
I'm
Right?
saying like the test might not catch it since the behavior is.
What do you mean?
So like if someone had implemented it with only like the equal check without the value, it would have the same behavior if you pass in an object that doesn't override the default object values.
We'd have to look at specific cases, but you don't want to write code that works right only under certain circumstances, right? You want to write it so that it'll work even if people override and add the right stuff.
I mean, yeah, fair, but that's just the reason why it might not.
Oh, might not catch it. Okay, I understand. Yeah, yes, that's a good point. Okay, so what's wrong with this code? So what it wants to do is it wants to be able to add A to the end of whatever's in element data. Yeah, it just overwrites it, exactly. So it's not actually adding it to the end. It's just replacing it. So that's incorrect. This is kind of what I was saying before. Try to avoid using helper methods that have additional stuff that you don't need to do your job. Now, it's fine to have helper methods, don't get me wrong, but they should do the thing that they need to do and no more, because otherwise you're just making an overhead for no reason. So you shouldn't use ensure internal capacity for that purpose. It does have a purpose, but not for that purpose. This code is just too complicated. It can be simplified quite a bit by using other mechanisms, and it's also missing a check for exception. A lot of people kind of got carried away with calls to various things, and we'll see a bunch of examples of it. This is one. Add all. By the way, my implementations of add all, I wrote an internal helper method, which kind of factored out the common code, and then both of my add all methods called that helper method. The problem here is you can do all this stuff with really just a call to copy of, and one call to arrays copy of, and one call to system array copy. So if you have more than that, this thing has like tons of copies and allocations. It's way too expensive. So simplify it. Shouldn't have more than one of each to do add all. This code is a little hard to tell why this is wrong, but you have to look at the implementation of that thing. But the thing to notice here is that you should be passing in m size plus 1 to ensure capacity internal, and that wasn't. And internally, it worked in a way that was always reallocating memory. Yeah.
So, would it be too much? Do you think it's a good idea, or would it be too much overhead to invoke add and add all? So write add all that way, or do you think we should do it completely separate?
So, if you use add to implement add all, you're undoubtedly using a loop. I mean, you could do it other ways, but you're probably using a loop.
Yeah.
So you should try to avoid using the loops for that. So instead, use the depends on which one it is. If you refactor it, it's really clean. But you could use toArray if it's the collection one. You could also use copy of, or system array copy. Those two things work together nicely. What I did is I used copy of in order to be able to make a new array that was a copy of the old array that was bigger. It was big enough to hold both the original and the new one. So that made a big chunk, but it only had the first chunk allocated or copied. And then I called array copy to copy the rest of it into that. And so that's nice and clean and efficient. Okay, a common problem in remove, you don't always have to slide everything down. So if you remove the very end element, you don't have to slide anything down at all. Only if you remove something that's not the end, you have to slide things down by one. And so you need to have this check in there. So you don't just unilaterally always copy in remove. And then a lot of people also did wacky things. Remove did a lot of wacky stuff. People would end up making way, way, way too many copies, or allocating stuff. It was nuts. So it's really, really simple. And make sure that this particular code was not resetting m size, so it wasn't actually removing things. Don't use a loop. Use the array copy stuff, because that can be optimized much more efficiently. here was an example. A couple people did something like this. This is just chock full of stuff that's unnecessary, right? So don't call range check and call get, because that's redundant, right? So call range check and then have an unchecked get, or something that'll get the element more efficiently. Then there's just a lot of extra stuff, way more extra stuff going on. I'm not even sure what it's doing, but whatever it is, it's way more than you need. You don't have to do anywhere near that amount of copies. You also don't have to check to see whether something is empty, right? Range check will catch that for you. Yeah.
Shouldn't we always have at least one system.array copy that
Yeah. Well, yes, but it only should be called if you actually have to shift things down. So yes, the right implementation of remove is one call to system array copy. Exactly. Yep. And don't make. Oh, okay. So here's get. So get doesn't have to check if it's empty. Range check should catch that. And don't make this check here. It doesn't belong there. Here's a crazy implementation of set. So this is set. Set is trying. The semantics of set are that it's going to go to the ith element if one exists. Otherwise, an exception is thrown, and it's going to replace the value of the ith element with the parameter that's passed in. That's all it's doing, right? It's already assuming the memory has been allocated, and it's not allocating new memory. So all these calls to make new objects, that's inefficient. Array copies, having two array copies don't belong there. Don't use get in set for the reason we talked about before. It's doing a superfluous, redundant, unnecessary, duplicative, pick your favorite descriptor. It's doing something that's unnecessary because we already know that by calling range check if it's going to work or not. Once again, don't call get in set. If you want to call a method, make your own internal unchecked get that doesn't check the range. A couple people got the range check wrong. This is really subtle and will cause your code to blow up in weird ways. So you have to do the right check. Ensure internal capacity internal. Someone was calling toArray in the middle of that. I don't know why. That didn't make any sense. And then that code was also making a recursive call to ensure capacity internal. And I didn't really look carefully enough at the code to see if there was some basis condition where it would stop recursing, but boy, that looked suspicious, right? That code could run for a very long time until your program blows up and runs out of step. This is the wrong check to see whether something's equal. Just use the equal operator, not equals. I know that's confusing, but that's what you have to get used to. And this is way too many copies. It's log n copies. You don't need to do that. Just set the value, and then you can make the copy one time. A lot of people's code didn't handle the case where m element data equals s empty element data. In other words, when this is when add is called for the first time after you make a default sized array, and we want to allocate the memory to the default size in that case. This is too complicated. You don't need to use copy of here. Then the next set of things are for grad students who are doing the iterators. So there's a next method, and the simplest way to implement next is to use get as part of the implementation, because get will check the bounds and will throw an exception if it needs to throw an exception. You don't have to do an extra check in there. Next, here's another implementation. This is redundant. There was a call to get later, and that was redundant. And then next and remove need to set this thing called last element. And by the way, the undergrads, you guys have to do this for the next assignment, so pay attention to this. You have to set this flag, this field called last element, to keep track of the last place that you checked, you did a next on, because that way if you're going to remove something, you know where you left off. And those are just the semantics of how iterator remove work. And this code is too simple because it doesn't do the right checking. Okay, so that was basically the assignment. Those were the things I saw most commonly made mistakes. Some people have very few of these. Some people have quite a few of them. If you have quite a few of them, I probably sent you an email and said, we need to talk, or you need to think about what you're doing. If you found this code really hard to implement, then it's going to get a lot harder in the class. This is meant just as a warm-up to get people back up to speed with Java. So think carefully about how well you understood what we covered. Any questions?